Hi, this is Jason Baker, and we're back again to continue our lecture today and talk a bit about Linux, the Linux operating system. The Linux operating system was started by a fellow by the name of Linus Torvalds back in 1991. And at that time, he was looking to basically create his own version of the Unix operating system. The Unix operating system had powered servers on college campuses and at large corporations since the 1970s, where it was developed by the folks at AT&T and T and Bell Labs. Now back in the 80s and 90s, if you wanted to install Unix on a machine, you basically had to get a commercial license, and the licenses were very expensive. So if you were a hobbyist and you wanted to play with a Unix-like operating system, you really didn't have many options. And so Linus went ahead and created his own version of Unix. Now it's important to note that Linux is not Unix. Linux is like Unix in the sense that Linux implements the same sort of API as a Unix operating system, which means that when you're using Linux, it feels and works a lot like Unix. One of the biggest differences is that the Linux operating system is completely open source, and it's open source using the GPL, the general public license, meaning that anybody in the world can use the Linux operating system for free. Now, it started in the early 1990s, but Linux has grown over the decades and has become one of the most prolific operating systems in the world. And it runs everything from Android cell phones to some of the largest supercomputers in the world right now. So Linux is really powering uh, just millions and millions of devices. In my experience, Linux is also the most prolific operating system in the cloud right now. And for companies that are building modern web applications, oftentimes those applications are being powered by a Linux operating system. When we talk about Linux, when you hear people talk about the Linux operating system, oftentimes they're talking about a Linux distribution. And a Linux distribution is a suite of software that includes not only the operating system kernel, but also a collection of, of applications that are packaged along with the kernel. And there are a number of different distributions that are available in the marketplace, and you would generally pick a distribution that meets your particular needs. There's companies like Red Hat and SUSE. There's the Ubuntu distribution. There's open source distributions like CentOS and Debian. And well, all of these distributions are open source, but you can also get commercial licenses from companies like Red Hat, so that you can get commercial support for your Linux distribution. In the course this semester, we're going to be using the Amazon Linux distribution running on AWS EC2 instances. Now, Amazon Linux is a special Linux distribution that's maintained by AWS. It's what we call rolling release, meaning that AWS is constantly sort of updating its Amazon Linux distribution, which means that if you if you deploy an Amazon Linux instance this week and then deploy another one next week, the version and next week might have some newer packages or might have some kernel updates on it. Amazon's constantly updating their distribution. Amazon Linux is based on Red Hat Enterprise Linux. So that's sort of its lineage. If you're working in a company today and you're using Red Hat Enterprise Linux or CentOS, then you'll feel right at home with the Amazon Linux distribution. Now, no matter what Linux distribution you use, what you'll find is that most of the basic operating concepts are the same across distributions. You can use Amazon Linux, and then you can switch over to Ubuntu Linux, and most of the concepts are the same. What you'll find is that there are some key differences in the way that applications are packaged and installed on these different Linux distributions. You also find that uh, some Linux distributions favor certain software packages over other Linux distributions, and you'll find that configuration files are potentially located in slightly different places. But for the most part, if you move from one Linux distribution to another, you should be able to work with it just fine. Now, in order to access Amazon Linux on AWS, there's a couple different things that you need. The first thing you need is an Amazon EC2 instance that's running in the cloud. An EC2 instance is your own private server, and on that server you'll install Amazon Linux. In order to access that server, you'll need a set of keys. You'll need a public and a private access key for each EC2 instance that you launch. We use we use we use these keys in our course instead of things like usernames and passwords. The keys are much more cryptographically secure than any password. And then finally, in order to access the Linux server in the cloud from your desktop machine or your laptop, you're going to need a software client. You're going to need something called an SSH client, a secure shell client. This is an application that allows you to create a remote terminal connection to that Linux server. This allows you to log into the server remotely and then run commands on a from a terminal prompt, from a command line on your local workstation. If you're using a Windows machine, then my recommendation is to use a software application called Putty, which is freely available. If you're using any of the campus machines, then Putty is already installed on the workstation for you. I use a Mac OS primarily, and on Mac, I use a software application called iTerm2, which is also freely available and does everything that you need. Finally, if you're using a Linux-based machine or a Linux virtual machine, then you can use Xterm or whatever your favorite terminal is. Any of these options will work fine. Now, I have a couple of separate videos available which show you how to log into how to launch a new Amazon Linux EC2 instance, and then how to log into that instance using either Putty or iTerm. And so that'll be available to you, and you'll need to understand how to do that in order to work on your assignment. Okay, so let's start talking a little bit more about the Linux operating system. The first thing you need to understand, and probably one of the most important things to understand about the operating system, is the file system hierarchy, how files and directories are laid out in the operating system. In a Linux system, the file system hierarchy looks like a tree, and everything starts from this root directory, which is designated as the forward slash directory. So a forward slash means that you're at the root directory of the file system. And then from the root directory, you can access a number of subdirectories, such as bin or slash etc, which we sometimes call etc, slash home, slash lib, and so on. All of these subdirectories contain sets of files. And generally what you'll find is that each subdirectory contains a different type of files, or files which have a, a, a particular purpose. For example, the slash boot directory will typically contain the operating system kernel. The slash bin directory and the slash sbin directory will oftentimes contain software applications, programs that you might want to run. The etc directory generally contains configuration files. These are text files that you can modify. And these configuration files control how different applications and services on the system how they run. The home directory is where you'll find user files. When you have a user account on the system, you'll have a user account located in the home directory or underneath the home directory. The var directory is a common location for log files. You'll find a subdirectory of the var directory called log. So you'll have a slash var slash log directory, and in there you'll find text-based log files for different services that are running on the system. You don't necessarily need to know the purpose of every single one of these directories. I just want you to get sort of an overall understanding of the layout of the Linux file system and where you might find things. If you're accustomed to working on Windows, then you'll see a lot of similarities. These directories are just like folders on a Windows system, and you know that there's special folders in a Windows system, like the program files folder or the Windows or like Windows 32 directory. These directories contain special applications, or they're sort of designed to support different types of applications. Same sort of thing with the Linux file system. When you now when you're working with the Linux file system, you're obviously going to be navigating different directories on the file system, and you'll be working with different types of files. When you list out a file on a Linux file system, and you run this command ls-l, that will give you a list of the contents of a directory on the Linux file system. And when Linux lists out the name of each file, it precedes the name with a block of characters. And this block of characters has a special meaning. For each file in the directory listing, Linux is going to tell you is going to give you some information about that file, and it's going to tell you the purpose of the file. The first character in each file listing will tell you what type of file it is. So for example, a regular file will start with a dash in this listing. You can see that this first file is an ordinary file. The second file starts with a D, which means that it's actually a directory. And this sometimes confuses people a little bit. In the Linux file system, really everything is a file. Even a directory is sort of a file. You can think of a directory as a file which contains an index which points to other files on the file system. And there are a couple other devices. There are symbolic links and there's block devices that you might encounter as well. We're not going to be using those for the most part in this course. The other part of the file listing, this block of characters in front of the file name, tells you a little bit about the permissions, the access control list, if you will, to access a file. On a Linux file, the Linux file system is very secure, and you can apply security controls to different files on the file system to prevent people from reading and accessing files, to lock files down so that only administrators can access them, and so on. This block of characters in front of a file is separated into three groups, into sort of three subsets. Remember, the first character describes what kind of file you're looking at, if it's a normal file, if it's a directory. The next three characters tell you the user permissions. So each file on the system is owned by a user. And these permissions tell you what a user is allowed to do with the file. So in this case, the user is allowed to read, write, and execute the file. The next three characters describe what a group is allowed to do to a file. Every file on the system is also associated with a group. So every file in the system has an owner. Every file in the system is associated with a group. In this case, the group members are able to read or execute the file, but they're not able to write it because there's no W, there's a dash character. So the group members are able to read and execute, but not write to the file. And then the last three characters specify what everybody on the system is able to do. So everybody else, or we call others. Other users are able to read and execute this file, but not write, not modify that file. We'll see some examples of these directory listings here shortly. So if some of this isn't making sense to you, don't worry. As you work with the Linux operating system and as you begin to sort of like set permissions and change the ownership and so on, then some of these concepts might make more sense. Linux file names are case sensitive. That's really important. In fact, most everything that you'll be doing in this course, every technology we use is pretty much case sensitive. Not only are files case sensitive, but the commands that you run on the Linux command line are also case sensitive. When in doubt, type everything in lowercase because pretty much all the commands are in lowercase characters, and that's generally the practice, right? Is that when we're working with files, most often we're using lowercase letters. The other thing to note with Linux files is that Linux file names don't have dot extensions on them like Windows. Now, like in the Windows operating system, if you create a file and add a .txt extension, then Windows treats it like a text file. Or if you add a .exe extension, then Windows treats the file like it's an executable file. Linux doesn't care about dot extensions. In practice, we'll use dot extensions in our files. But we'll use a dot extension like .txt or .conf for config or .sh for shell script. We'll use these conventions just so that as humans, when we're looking at a file listing, we have some sense of the purpose of a file. But Linux doesn't really care at all what we call a file or if we add any sort of dot extension to it. On the Linux operating system, if you a file system, if you start a file name with a period character, then that file is called a hidden file, and by default won't be displayed in a standard directory listing. And we'll probably see some some examples of dot files. You can list a dot file by using the ls-l command, which lists all the files in the directory, even the hidden files. But a standard directory listing, when you just use the ls command, it will not show these hidden files, the files that start with a period character. Okay, so when you log into the Linux server, when you log into your AWS Linux instance, the shell application on your desktop is going to log you into the Linux shell on the remote Linux server. So you'll be at a command line. You'll see a command prompt. You'll be working directly with the bash shell on that Amazon Linux server. And when you're working with the bash shell, you can use a number of powerful uh, commands, sort of shortcut keys, when you're working at the command line. And let me see if I can give you sort of a quick example of some of the things that you can do here. I'm going to jump to a command line here and give you an example. So if I were to run a command on my system, so I could do like an ls var log command. So I'm typing in this command within the shell on my system. If I want to move to the beginning of the line that I'm currently at, I can just hit Control A, and my cursor will jump to the beginning of the line. I could hit Control E to jump back to the end of the line. If I wanted to clear my display, let's say I had some information on my screen and I wanted to clear it, I could just type in clear. I could also hit Control L, and that will also clear my screen. Sometimes that can be helpful if you've run a bunch of commands and you kind of want to start over, start fresh with a clear screen. You can use the up arrow key to run a previous command. So I'm just hitting up arrow, and that's scrolling through the previous commands that I ran on my system within this shell. Every time I run a command in the shell, that command is saved to a history, and that history is really convenient to access because I can use the up arrow key and the down arrow key to kind of scroll through all the commands that I was running previously. I can use the tab key to autocomplete my commands. So I'm going to create a command I'm going to create a file real quick on my system. We'll just call it web server conf. You see, if I do a directory listing, it shows that I have a webserver.conf file. If I wanted to look at the contents of this file, I'm going to use a command called the cat command. If I want to look at the contents of this file, I could say cat and I could type in the full file name. But if I want to save some typing, I can just type in cat and then I can type in something like web, then hit the tab key, and the shell will autocomplete. So the shell will look for any files in my current directory that start with WEB, and if it finds one, it'll autocomplete the rest of the line for me, and it saves me some typing. I use the tab character all the time, and you'll find that experienced Linux and Unix people use autocompletion quite a bit because we don't like to type. We hate typing, and so we're trying to be as efficient as we possibly can. If we can use auto completion to kind of speed up operations, then we'll do that. So there are a number of different shortcuts that you can take advantage of when you're working within the Linux shell. Okay, so um, let's jump into some of the commands that you're going to work with on a weekly basis when working with Linux. And for this part of the presentation, I'm going to actually initiate a remote terminal connection into an Amazon Linux server. So I've just uh, created a secure shell connection into the remote Linux server. You can see it's running Amazon Linux AMI. Secure shell creates a cryptographically secure connection to this remote server. All of the traffic, all of the communication, these commands that I'm entering, the data that I'm providing to this server, all that communication is encrypted between me and the server and from the server back to my workstation. I've logged into the system and now I'm at a command prompt. You can see that the command prompt is giving me some information about this server. It tells me that I'm logged in as a user. I'm logged in as a special user called the EC2-user. That's basically my username. That's my user account, EC2-user. And it's telling me the name of the server. By default, a new Linux AMI or Linux EC2 instance is going to have is going to be given a name based on its private IP address. In this case, 172.31.55.193. And then you see this $ characters. That's the command prompt, and my cursor is located after the command prompt. Okay, I've logged into the remote Linux system. One of the first things I'll show you is the help system. You can get some help information when when working right within the Linux shell. And there are a couple different command ways that you can get help from the system. One is to use the man command. Man stands for manual. So we'll look at our directory listing command. We'll do a man space ls. And if I do that, then some helpful information pops up about the ls command. It tells me the ls command is used to list directory contents. It tells me, gives me a synopsis of how this command is used, and then it describes all of the different command arguments and attributes that I can set when I'm using this command. One of the attributes I've been using is -l, which means use a long listing format. That gives me more information about a directory. If I do an ls-l, In this case, I don't have any files in my directory, so I'm in an empty directory at the moment. Sometimes when I'm using commands, I can do something like I can do something like um, use a dash dash help argument on the command. I don't know if ls actually supports that. Well, it actually does. So that's another way I can oftentimes get some helpful information about a command, is to type in the command name, space, and then dash dash help. Use dash dash help as one of the arguments. A third way to get information about a command is to go to your favorite web search engine. In other words, just sort of like Google for some documentation about the command. And oftentimes that's the method that I'll use, is because sometimes this help information is a little bit terse and I'm looking for more details, or I'm looking for some examples of how people are using a command in a particular situation, and I'll look for examples on a search engine. When you log into the Linux system, you're logging into that Linux system with an account. So you provide a username, and the default username that we'll use on these Amazon Linux instances is the EC2-user account. That account is installed for us by default. When we log in, we're not providing a password. We're providing a private key that we generated when we created the EC2 instance. And you'll learn more about that in the video that I prepared for you, showing you how to create your first EC2 instance, and you'll be using this throughout the course. Every user account on the system is typically a member of at least one or more user groups on the system. And there's a special account that's available on every Linux system called the root account. The root account is also known as the super user, and this is the all-powerful administrative account that lets you do absolutely anything on the system. The root account is like the administrator account on a Windows system. When we log into the Linux system using our EC2-user account, there are times where we might need to escalate the privileges of our account so that we can perform certain operations. For example, if we want to install new software on the Linux system, typically we'll need to be a root user. We'll need to be a super user on the system in order to install software. In order to become super user on the system, we need to use the sudo command. We need to precede our command with the sudo command. For example, if I want to run, let's say I want to modify a file on the system. We'll just go into the etc directory and let's see if we can sort of pick a file. So maybe we'll pick the hosts file. And I want to modify this file, and I'm going to create another host. I'm just making these numbers up right now, so I'm going to make up an IP address and call it my host. I'm using a text editor, by the way, called VI to modify this configuration file. So I'm going to try to write these changes, and the system isn't letting me write. It's telling me that I only have read-only access to this file. That's because I don't have enough access privileges. If I look at that host file is owned by the root user on the system. And because I am not the root user, I cannot modify that file. In order to modify that file, I would need to run the sudo command. So I need to do sudo vi hosts. And now I can make modifications to this file. I no longer have read-only access. I have write access because I've escalated my privileges. Now I'm basically running as the root user on the system. Windows has a very similar concept. In Windows, you can run an application as an administrator. Perhaps you've seen that option when you like right click a file in Windows, you can an executable file, you can run that application as an administrator. That's allowing you to escalate your privileges in the system. The same sort of scenario on Linux. You can run programs as the root user on Linux by using that sudo command. Well, and before I continue, somebody always asks me a question in every one of my classes, and the question is, well, how do you know when to use the sudo command? Uh, that's something you sort of learn over time, and with practice, you'll understand which operations require the sudo command and which ones do not. But generally, if you're trying to modify files that you do not own, you need to run the sudo command and escalate your privileges. If you're trying to install new software on the system, then you need to use the sudo command. You need to precede your software installation command with the sudo command so you have the proper root privileges. Every user on the Linux system has their own defined home directory. And the home directory is located in the /home subdirectories. Remember that the slash directory is the root. If I go to the slash directory on the system, and I'm going to clear my screen and do an ls, here are all the subdirectories that are part of the slash directory in the system. You'll probably recognize some of these names from that hierarchy slide that I showed you earlier in the lecture. One of these subdirectories is the home directory. And within the home directory, if I do a listing, you'll see that there's an ec2-user directory. Remember that ec2-user is the default user that's set up for us in the Amazon Linux instance, and that's the user I logged into when I accessed this system using my terminal program. Every user on the system will generally have their own private home directory, which is located on under this /home subdirectory. So if I want to refer to this ec2-user directory, I can refer to it by just saying, list the contents of /home /ec2-user. That's one way to refer to that directory. There's also a shortcut available to us within Linux, and that's the tilde character, that little squiggly character in the upper left part of your keyboard. The tilde character is a shortcut reference for your home directory. So anytime you use that tilde character, that's referencing your home directory on the system. If you wanted to add new users into your system, into your Linux server, you could use the user add command. So you could say user add Steve, and it would add a new user on the system called Steve. If you wanted to delete users on the system, then you can use the user delete command, user del command. In this course, you'll find that we're not going to be really adding and removing users on systems. We're going to be pretty much just sticking with the EC2 user account for most of the course. But I encourage you, if you want to just play with it on your own, if you'd like to add or remove users, go ahead, just so you can just to kind of learn and exercise these commands a little bit. I already talked about the Linux directory. It's a tree structure, and everything starts with the root directory, which is denoted by this / character. Um, Whatever directory that you're currently in, as you're sort of navigating through the file system on Linux, your current directory is called the current working directory. And you can use the pwd command to display the current working directory that you're in. So if I type in pwd, then it just says, it gives me the / character, which means I'm at the root directory. If I change my directory to /home /ec2-user and then run pwd again, it tells me I'm currently in the home /ec2-user directory, which is what we would expect. The pwd command is helpful because there are times where you're sort of navigating through the Linux file system and you're changing directories, and you might lose track of where you're currently at, which directory you're currently in when you're on the server. And so you can use the pwd command to kind of quickly figure out which directory you're currently working in on the server. We've been using the change directory command to change our current working directory to a new one. I'm in the home ec2 user directory. If I want to change to the home directory, then I can just say change directory /home. Now I'm in the home directory. There's also a change directory on Windows. It works exactly the same way. Lets you change from one directory in the file system to another directory. When you're changing directories on the file system, and when you're referencing directories in the file system, you can reference directories in two different ways. You can reference directories by specifying an absolute path name. And an absolute path name, we're specifying the directory location from the root directory on the system. So it's an absolute reference that's based on the root of the file system. So for example, if we do change directory /home /ec2-user, that's an absolute path reference because we're referencing this directory from the root directory. So anything that starts with the / is an absolute path reference. The second way that we can reference a path is from using a relative path name. For example, I can change directory. In this case, it's saying change directory to documents. I'm currently in the /home directory. And I can say change directory to ec2-user. And now I'm in the home ec2-user directory because I knew that ec2-user was a subdirectory within the home directory. I didn't have to reference the ec2-user directory from the root path, from the root directory. I didn't have to say change directory /home /ec2-user. I could just say change directory directly into ec2-user. Because I referenced this subdirectory name directly without using the root path, that's what we call a relative path name. It allows us to change to a subdirectory based on the location of the current present working directory. Okay, I'm currently in the home /ec2-user directory. What if I wanted to go back to the home directory. I could say change directory slash home, but if I just want to go back one directory, if I just want to go back up to the parent directory of my the current working directory that I'm in, I can just say change directory dot dot. If I look at my present directory, I'm back in the slash home directory. So if I say change directory dot dot, that will change me to the parent directory of the current working directory that I'm in. If I want to change to my home directory on the system, I can just say change directory to tilde. Change directory to tilde. Again, it shows, you can see that I'm now back in that slash home slash ec2 dash user directory. You'll get really comfortable over time navigating the Linux file system because you'll be doing it in most every assignment this semester. You'll be changing directories and creating files and doing different things. So this is, I just want you to understand sort of the basic navigation as you go up and down the Linux file system, as you change from one directory location to another. You can use absolute path references. You can use relative path references. It can be very easy, especially if you are new to Linux and if you're not accustomed to working with command lines. It can be very easy to kind of get lost. And so the key is to try to maintain this mental picture of where you're at, what you're working on in the file system. And if you get lost, use that pwd command to figure out the current working directory. Okay, we've been changing directories. We're currently in the home slash ec2 user directory. Let me clear the screen here, sort of start with a fresh slate. So I'm in my home directory. I can use the make directory command to create a new directory. When I create a new directory, that directory is going to be created as a subdirectory within my current working directory. For example, I'm just going to say make directory test. If I use the directory listing command ls, it'll show me that I have a directory called test. If I do an ls-l, that'll give me a long listing. So here's my directory called test. I know it's a directory because this block of characters in front of the file name tells me that this is a directory file. And if you recall, you can see that the user has read, write, execute access, the group has read, write, execute access, and everybody else in the system has read and execute access. This file or this directory is owned by the EC2 user, and there's also a user group called EC2 user. So that's the owner and the group that's associated with this directory. If I don't want this directory anymore, then I can remove it. I can just use the remove directory command. So I'll say remove directory test, and it's gone. If I have a directory on my system, so I'm going to create another directory. I'm just going to call it my files directory. And I'm going to change to that directory, list it. There's nothing in there. It's an empty directory. I'm going to create a file. I'm just going to call it fake.txt. So now there's this empty file in there. And if I change back to the parent directory, I do cd ... I'm back in my parent directory, ec2-user directory. Now if I try to remove that directory, the Linux file system won't let me remove that directory because that remove directory command will only work if the directory is empty. But because there's a file in there, even though the file itself is empty, because the file exists, I can't use that remove directory command. One way to remove that directory is to use the rm command and to do a force removal. So I can do an rm-fr on the files directory, and that will forcibly remove that directory and delete any of the contents, any of the files that exist within that directory. This is a very powerful command and a potentially very dangerous command. You could inadvertently use this command to delete all of the files in your system if you're not careful. So anytime you use this command to delete an entire directory and all the contents of that directory, you have to be especially careful. We can use the touch command to create files. You saw me use that just a moment ago. I'll make my files directory again and change into it. And I'll do a touch myfile.txt. That creates an empty file on the system. It's empty because if I do a directory listing and look at the size of the file size is 0 bytes. So the file doesn't contain any contents. The touch command allows me to create just like an empty file. Now, if I want to modify the contents of this file, I can modify the contents by using a text editor. And these Linux distributions, Amazon Linux includes a couple different text editors that I can use. There are two that I recommend you trying in this course. If you're a beginner and you've really never used Linux before, then I recommend using the Nano text editor. If you're experienced with Unix or Linux, then you could use VI or Emacs or whatever your favorite editor is. Let's try Nano. If I use the Nano editor, if I type in nano myfile.txt, then I'm running the Nano text editor application. This looks kind of like an old word processing application from the 1980s. It's just a really simple text-based editor that I can use. But it does the trick. So I can add, this is my file content, and I'm going to do Control O to write out this file and hit enter the name I want to write. I'm going to say Control X to exit it. And now if I want to look at the contents of my file, I can use the cat command. I can cat out, or I can display the contents of my text file. And you can see that here's the contents I had typed into that file using the Nano text editor. There are a couple different ways to display the contents of a file. You can use this cat command. Another command you can use is the more command. So the more command is nice if you've got a file with a bunch of different text in it. The more command will actually paginate the file. So if you've got a long file, you can kind of scroll through it page by page. The other command you can use is the less command. And the less command also provides pagination. Another method is that you can always open up the file in a text editor. So you could always open that file again in Nano or VI, and you could look at the contents of the file that way as well. You've seen a couple different ways to list files. We use the ls command to list files in a directory. If we want to get all the full detailed information about the files in our directory, then we can use the -la attribute. So we can do an ls-la. When we're working with files, oftentimes we want to be able to copy or remove files from a directory. To copy a file, I use the copy command. So cp, I can say myfile.txt, and we're going to copy it to myfile.bak. If I do a directory listing, now you see that there's two files. If I cat myfile.bak, you see that the contents of that file are the same as the original file that I created. If I want to rename a file, let's say I gave a file an incorrect file name, I can rename it by using the move command. I can move myfile.bak to backup file.txt. Do a directory listing, and you see that it renamed that .bak file that I had created. And then finally, if I want to remove a file, I can use the rm command to remove the file. So I can remove the backup file.txt, do an ls, and now that file has been removed from my system. The last thing I'll point out related to the Linux file system are file permissions. If I look at myfile.txt, you can see that it's owned by the ec2-user account. You can see that account has read, write permissions. The group has read, write permissions, and everybody else has just read permissions. I can change the ownership of a file on a system to another user. I'm going to add user jbaker. Oh, here's a good example. So I tried to add a new user to the system, but I got a permission denied. That's because the ec2-user account does not have appropriate privileges to add new users on the system. I have to escalate my privileges to the root user in order to add new users on the system. So I went ahead and I added a new user in the system called jbaker. Now I want to change the ownership of my file to jbaker. So I'm going to say I'm going to do that by using the change ownership command or the chown command to change the ownership of my file to the jbaker user. Again, in order to do that, I need to have super user privileges. So I need to use the sudo command, sudo chown jbaker myfile.txt. Now if I do a directory listing, you'll see that my file.txt is owned by the jbaker account on the system. If I want to change the group, then I can use the change group command. Again, I would have to use the sudo change group command to change the group from, the ec2-user group to some other group on the system. I can also modify these file permissions. Let's say I wanted to allow the user to execute this file. This isn't a script file or a shell script file, but let's say it was. If I wanted to allow a user to execute that shell script file, then I would say I would use the chmod or change modification command, chmod command. Let's say I want the user to be able to execute. I'm going to have to use sudo chmod user execute myfile.txt. Now if I do a listing, you'll see that the user is able to execute. So you see the X there. User is now able to execute this file, run it like it's a shell script. I did that by using that chmod command. And you'll use that actually a fair amount in this course. You'll find that anytime you're working with a shell script, something which should be executable, you'll need to modify that file and make that file executable by users on the system. Okay, we'll wrap things up there. And that's your sort of basic tour of Linux and the Linux file system. And next up, we'll talk about some more advanced capabilities within Linux.